Hello everyone, welcome to Algorithms Lab. So this program is called as the naive algorithm. So this algorithm is a string matching algorithm. It follows a brute force approach. We have seen the explanation of this algorithm in the theory video lecture in unit 1. So today we'll see the execution of this program or this algorithm. So this is a string matching algorithm uh, which is the most simplest string matching algorithm. But let's first see what is meant by string matching. So we have a certain string of characters, or we have a certain text present, and we are looking for a substring or a pattern inside that text or string. So there are many methods, there are many string matching algorithms available. We'll be studying this naive string matching algorithm or brute force algorithm for string matching. So since it is brute force, it employs a straightforward approach for matching for a particular substring. So it is the simplest of all the algorithms that are present, but it is highly inefficient. Now why is it highly inefficient is because it checks that pattern present inside that string character by character. One by one, every character present in that text is checked, and that is why it is highly inefficient. Talking about the complexity of this algorithm, the average case is order of n plus m, order of n plus m, where m is the size of the pattern and n is the size of the main string, whereas worst case scenarios order of n into m, n multiplied by m. So this algorithm is generally used for smaller texts. If you have a very large text, then this becomes very highly inefficient. So for smaller text, this algorithm can be used. All right. So let's see an example. I have a particular pattern over here. Uh, I have a particular pattern over here with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 with 11 characters. With 11 characters, and I have a pattern called as P which has 4 characters. Which has 4 characters. Alright, so I want to match this pattern ACAD inside this string of 11 characters. So one by one, every character will be matched. If there is a mismatch found at any position, then that pattern will be shifted by one position to the right. This is how this thing works. So the first character is at 0th index. So this is s of 0. S of 0 refers to this main string. P of 0 refers to this pattern. So it will check whether s of 0 is equal to p of 0. Yes, there is a match. It will go for the second one. The loop is incremented. It will go to the next index, s of 1 and p of 1. It will check whether s of 1 and p of 1 have equal values. They don't have equal values. S of 1 is not equals to P of 1, which means that there is a mismatch. When such a scenario is encountered, wherever there is a mismatch, then this pattern, as you can see, it is shifted to the right by one character. It is shifted to the right by one character. Then again it will check S of 1 with P of 1. S of 1 with P of 1. There is a mismatch, or it actually has to be P of 0. This actually has to be P of 0. There is a mismatch. Next, when there is a mismatch, it has to be shifted to the next position again. Then when it moves to the next position, it will check for uh, these two index values or values placed at these two indexes R and A. There is a mismatch. Again it will go on moving. Again it is moved to the next character. So there is a match over here. These two characters match. A and A are matching over here. Since they are matching, it will check for the next matching character. C and C, there is a match. It will go for the next matching character. A and A, there is a match. It will go for the next matching character. D and D. So this pattern ACAD, it is found at position 3 in S. It will give us the first occurrence of the matching character. This is index value 0, 1, 2 and 3. So this A or this pattern is found at position 3 in this text called as S. So we can just print the index value of the first occurrence of that pattern, or we can print the index values of all the occurrences of that pattern present inside that string. That coding is left to us. We can design it any way we want. So this is how this is the working of that algorithm, right? Look for that pattern by checking every character present inside that text, right? Let's see how this program works. Okay, so I'm using dev C++. You can use any IDE that you want. You can use turbo C, you can use dev C++, you can use kdevelop. It's left to you. uh, so this is the program. I have a function called as pattern matching. It takes two parameters over there, the string and the pattern to be matched. So inside the main function, I have allotted 30 characters for the main string and 30 characters for the pattern. I am going to ask the user to enter the string and also to enter the pattern. Call that function pattern matching with these two parameters passed to it. Let's see the function. So this is the function pattern matching, right? So I'm going to first, this line is going to calculate the length of the pattern. I'm going to use a function strlen to calculate the length of the pattern, and this function is going and this line is going to calculate the length of the main string. All right, then I'm going to use a for loop. So this for loop starts from 0, it goes to string length minus pattern length, right? String length minus pattern length. What is the length of the string in that example? 11. What is the pattern length? 4. So 11 minus 4, only till here it is going to go. So 11 minus 4 is how much? 7. So only till 7 it is going to go, right? So as we go on shifting, we cannot exceed the shifting beyond the length of the main string. We cannot exceed it beyond the length of the main string. So this shifting is going to happen only for these many number of times. String length minus pattern length. String length in our case it was 11 and the pattern length was 4. So 11 minus 4 is 7. So inside this I have another for loop. Then it is going to check if strm plus n not equal to pattern of n. So we are going to check for the values present inside those uh, index values. Say m value is 0 and n value is 0. So str m plus n. So str of 0 not equals to pattern of 0. As we can see here, str of 0 not equal to pattern of 0. If it is not equal, then what do? We break. We come out of the loop and we increment the value of m, which means that we are going to shift the value of we are going to shift that pattern by one position. So till we are going to go on doing this till we find a particular match. So whenever we find a match, it is we are going to display its matched position, or we are going to display the index value where that pattern is found. So this is a very simple and a small program. Let's execute this and check. So compile and run. So it is asking me for a string. Let's say welcome to GIT. In this case, I'm not able to enter blank spaces. If you want to accept blank spaces as well, you can write the program accordingly. So it is going to ask me for a pattern to match. I'm going to say GIT. It is going to give me pattern matched at position 9. Let's do that again. Compile and run. Then enter a string. I'll say welcome to string matching. It is going to say I'll say 2. So pattern matched at position 7. Let's try one more. Say run. So enter a string. So I'm going to match for a pattern called as BA. Let's see. So see here, I have a main string, right, and I have entered a pattern to match. So all the occurrences of that particular substring is displayed. It is present at index value 2, or you can say position 2, then matched at position 5 and position 8. If you can count those index values, you will find these values, or you will find that this substring BA is found at these index values in that main string. So you can either do this, match all the occurrences, or you can either do match the first occurrence. So for your term work, we are going to display all the occurrences of a particular pattern in that string. So this is the program which is there for this naive algorithm. This will be shared on the Google Classroom. I hope this program is clear to you. We have already discussed the working of this in one of the theory lectures in the first unit. So this is one of your term work, naive algorithm for string matching. Execute it and check for the answer. Thank you very much.